Unit 1 is on the number system, specifically lesson 1 is on rational numbers. So when you talk about rational numbers, and what you need to know about rational numbers is that they are a comparison of two integers. Comparison of two integers in and of itself may not mean a whole lot to you, but it says right here that the root of the word rational is in fact ratio. So we're talking about a ratio of two numbers. You more commonly come across those, or you may think of those as fractions. So basically what I want you to think of rational numbers are anything that can be written as a fraction. So obviously a fraction is a fraction. So 2/3, come on pen, 2/3 is a fraction, 5/8 is a fraction, 6/7, 20, 29ths, anything like that, that is a comparison of two integers. So with that, mixed numbers. Say 2, that's a pitiful looking 2. 2 and 2/3. 2 and 2/3. Mixed number can be written as an improper fraction, so 2 times 2, which is 6, plus 2, 8, 8/3. 8/3, that is a comparison of two integers. A mixed number does not quite fit the criteria of a comparison of two integers, but it could easily be transformed to 8/3, which that would work. So when we talk about percents, let's say 58%. 58%, that is a percent, so percent means per 100. So 58%, 58 per 100, 58 over 100. And then you would need to reduce that. That would be 29 over 50. 58 over 100, 29 over 50. Any percent can be written as a fraction. So 8%, 8 over 100, reduce by 4, which would give me 2/25. Okay, any percent would work. Decimal, let's say 0.7. 0.7 is properly said as 7/10. 7/10. 0.19, 19/100. So just properly say the decimal and put it over that place value and reduce if you need. Okay? All right, moving on. Let's see what we got down here. Actually, I think we're just going to go ahead and go to the next page. Clear all of this off of here. And let's talk about rational numbers as part of the number system. So, rational numbers as part of the rational system, pretty well, I mean, there are rational numbers and irrational numbers, but for the purposes of this lesson, we're just going to focus on the rationals, which include all your fractions, decimals, percents, okay? They also include the integers, which we've done a lot of review work on over the last 2 weeks. They also deal with your whole numbers, which are 0, 1, 2, 3, 4, 5, and then just specifically your natural numbers, which are also your counting numbers. So they are the whole numbers minus 0. So focusing specifically on the decimal part of this, let's talk about repeating decimals and terminating decimals. Here's the main differences. Decimals, repeating decimals that keep going, so in other words, repeat, whether they repeat 1 number, 2 numbers, 3 numbers, whatever it is, repeating decimals, repeat. Terminating decimals, if something terminates, it stops, so it comes out even, okay? So whenever you have like 1/2, 0.5, and then the rest are 0, so it comes out evenly as 0.5, that's terminating. 2/5 comes out as 0.4, that is terminating. When you do something like 5 divided by 6, you get a big, long, ugly decimal, 0.83333, which never quits. That does not terminate, so that is a repeating decimal. So, moving up here. If we are going to take fractions and write them as a decimal, sometimes they will come out even, sometimes they won't. Let's talk about these two. So if we have 5/8, this fraction bar right here means division. So we're talking about 5 divided by 8. 5 divided by 8 comes out evenly at 0.625. That is a terminating decimal. -1 2/3. You can change this to an improper fraction and then divide 5 by 3. Or sometimes if you just will cover up this 1 and just say, okay, it's going to be negative 1 point something, and then if you divide 2 by 3, you will get a 6 that repeats over and over and over and over. So it is completely up to you if you would like to change it to an improper fraction and then divide. If you have problems remembering to put that whole number back on, that may be the choice for you. Or if you're fine with it and just want to deal with maybe different numbers, you can leave the whole number off till the end and then just remember to put it back on. So, repeating decimal. Put it over the first digit that repeats only. Do not put it over both of those because that is the same thing. So negative 1.6 repeating. So I want you to try these 4 down here at the bottom, A, B, C, D. In just a second, I want you to pause it, try those, and then I will tell you what the answers to those are. So hopefully you're back by now and you've tried them and you've had success. For A, you should have 0.75. For B, you should have negative 0.2 repeating. That's a 2. And the 2 repeats. Okay, negative 0.2 repeating. C, 4.52. And D, 3.09. And the whole thing repeats. This cursor does not let me write very pretty numbers or letters sometimes, so I apologize for that. All right, let's move on. Next page. Okay, and let's get all of this off of here. So we talk about Albert Pujols, one of my favorite players. In a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits in 530 at-bats. To the nearest thousandth, which is 3 places after the decimal, find his batting average. So if his batting average was 175 hits out of 530 at-bats, fraction bar again means divide, so you would take 175 and divide it by 530, you come out to this big decimal. And it said round to the nearest thousandth, which is here. So we look at the 1, it keeps the 0 the same. So his batting average, he was hitting 330 at that time, .330. So not bad, even if he went to play for the Angels, that's still pretty respectable. All right, looking down at the examples. Example 4. Write 0.45 as a fraction. Again, we talked about 0.45, and we could properly say that as 45 hundredths. So that is it as a fraction. 45 hundredths. 45 hundredths. All right, let's move down and see what else we got on here. I would say it's going to be some more for you to try in just a minute. But first of all, we need to deal with repeating decimals and writing those as fractions. In the book, it talks about kind of a lengthy algebraic way to make a repeating decimal into a fraction. I've got kind of a shortcut for this. So let's talk about the shortcut. And my page. There we go. Okay. It went a little too far, so let's see if we can go back up here. That's what I thought. It looked a little funny to me. Come on, technology. There we go. All right, let's look at this. 0.5 repeating. 0.5 repeating. Instead of doing all of this, there is a shortcut in that a number that is repeating is actually that number divided by 9. So when we talk about, let's just pull up the calculator here real quick. So if I have, come on, 0.5 repeating. If I take 5 and divide it by 9, guess what I get? 0.5 repeating. Now, don't pay much attention to this 6 here at the end because that's just the calculator rounding it because the 5 would have rounded another 5 up to a 6. Let's try something like 1/9. 1 divided by 9. 0.1 repeating. 2 divided by 9. 0.2 repeating. 8 divided by 9. Guess what it is? 0.8 repeating. Also works the same for other digits. So before we talk about that, let's look at this one. This is 0.5 repeating. So using our shortcut that we just did, 0.5 repeating. So if it's one digit that repeats, then it's going to go over 1/9. One digit that repeats will go over 1/9. So 0.5 repeating, 5/9. 0.5 repeating is just 5 over 1/9. One digit that repeats over that many nines. Let's say if it was like 0.21. 0.21. And both of them repeat. Then that means it's going to be 21. And if there's two digits repeating, it's going to go over that many nines. You would, of course, need to reduce that by 3, which is 7. That by 3, which is 33. So if it was 0.562 and all of it repeated, it would be 562 over 999. 1/9 for every digit that repeats. So that should get us through here. If you want to do or want to learn the more algebraic way, I would be more than happy to teach that to you too. But I would say most of you would probably rather avoid it. So let's just do this for now, and we'll see where this takes us. All right, so let's go to that example we were just on just a second ago. There we go. Write 2.18 as a mixed number in simplest form. Again, we just had just a second ago two digits that repeated. So if two digits that repeat, it goes over that many nines. So this first number, we know it's going to be 2 and. Since it's bigger than 1, it's just going to be a mixed number. 2 and. Two digits repeat, so it's going to go over that many nines. So if we reduce that, divide them both by 9, 2 over 11. 2 and 2/11, right there. 2 and 2/11 without having to do the algebra work for now. I mean, we're getting into algebra very soon, but for right now I want you to concentrate on how to change these numbers back and forth. So I want you to go ahead and pause it and try these got it, F and G right here, and then I will give you the answers in just a second. Okay, back with me. Here's what we got, F and G. If you take negative 0.14, and write that as a fraction, negative 7 over 50. G, 0.27 repeating. You got two digits repeating, so it would go over that many nines, and then reduced 3/11. All right, so for guided practice. I want you to maybe go ahead and pause it, try some of these, and then I'll tell you the answers here in just a second. I will scroll up while you wait. All right, hopefully you're back. Write each fraction as a mixed number. Write each fraction as a mixed number. And it went too far on me again. Come on, honey. This thing has a mind of its own. Come on, you ready yet? All right, let's go back. Okay, real quick. Number 1, 9/16, 0.5625. Number 2, negative 1.725. Number 3, 4.83, and the 3 repeats. Number 7, 0.438. Number 5, 8 over 25. And 6, negative 7/9. If you have questions, see me tomorrow.